Let's look at the remote edge side first. The VMware SASE is our secure access service edge solution that combines industry-leading VMware SD-WAN by VeloCloud with secure access. The solution can be deployed leveraging a unique global network of cloud service nodes, the SASE POPs. Visibility at the edge is key. Here is the SD-WAN Edge Network Intelligence dashboard with all the remote locations that are being managed. Sites are marked in red when the user experience is poor. Let's click now on a problematic site. The HR application is experiencing poor performance, and several users are impacted. There is no problem on the Wi-Fi side, and this incident is root cause to a high TCP latency over the WAN connection. Let's move over the WAN and data center to investigate the user transactions going through the NSX Advanced Load Balancer. There is an increase on the server-side round-trip time and application response time, which further suggests an issue on the data center side. A service performance dashboard confirms the HR benefit service was degraded based on a latency SLO violation. A transient anomaly is observed when the P99 percentile latency crosses a critical threshold, reflecting a bad user experience. Time to get an end-to-end view. The VMware vRealize Network Insight monitors end-to-end connectivity for remote sites, data centers, and public clouds. From a single vantage point, users' activity can be tracked as they reach out from the remote locations across the SD-WAN back into the East Coast data center where the HR application is hosted. Broad visibility in this heterogeneous environment represents a key advantage. It gives the ability to pinpoint issues across the virtual and the physical layer to quickly identify the source of the problem and drill down to investigate. The automatic discovery of a performance baseline allows to detect flows with abnormal latency. This information, correlated with the flow count, shows that the service degradation occurs when a large number of employees try to access the HR application. Thankfully, the real-time application analytics can be used to automatically scale out load balancers and applications. The NSX Advanced Load Balancer controller seamlessly autoscales load balancer by bursting to the cloud and uses GSLB capabilities to balance traffic between the data center and the cloud. Since the NSX Advanced Load Balancer natively integrates with the underlying cloud or data center environment, the controller can also trigger the autoscaling of backend application servers. The Advanced Server Load Balancer configuration now shows new instances of the load balancer on-prem, in the AWS cloud, and a global server load balancer. The dynamic autoscale operates across multiple public clouds like Azure, AWS, and different on-prem geographical locations like the East Coast and the West Coast of the US, adding capacity close to the users. NSX provides connectivity and consistent security for all the applications in this heterogeneous domain. The newly created clusters are now part of a single global namespace which defines the application boundaries. The resources and the workloads that make up the application are distributed across all the data center locations, AWS and Azure. All the services in the global namespace use the same service discovery domain with end-to-end encryption.